Good day, class. So, let us now talk about the ideas na napapaloob sa ating bomba or pumps. Noong nakaraan, pinag-usapan natin yung Bernoulli's equation kung saan dinidetermine natin yung total dynamic head. At para saan ba natin magagamit yung total dynamic head na yun? Or yung head total na yun pagdating ng ating pump. So, let us see. Now, before we proceed, kailangan i-define muna natin what are pumps. So, the main purpose of a pump is to transfer a fluid from a region of low pressure to another region at the same or higher pressure. Nagdadagdag siya ng energy dun sa fluid para ma-transport mo yun. Now, meron tayong dalawang uri ng pumps. Okay? Merong positive displacement and then merong dynamic. What is positive displacement? Pag positive displacement, impellers pass on velocity from the motor to the liquid which moves the fluid into the discharge port. Ito yan. Ito yung impeller. Yan yung mga fins, okay, na parang bucket or scoop na tumutulak dun sa iyong fluid. Hindi kinocompress. Tumutulak lang. Okay? Tinutulak niya yung fluid para magkaroon to ng energy na gumalaw. Now, it produces flow by creating pressure. Nag-create ka ng pressure by continuously pushing the fluid. Now, for dynamic, traps confined amounts of liquid and forces it from the suction to the discharge port. Produces pressure by creating flow. Yung, mas maganda ipaliwanag muna natin sila kung ano-ano ba yun. Now, for the pumps, meron tayong positive displacement and then meron tayong dynamic. Now, merong iba't ibang uri ng positive displacement. Meron tayong rotary, ibig sabihin, umiikot from a single shaft. A reciprocating or paulit-ulit, meron ding linear. A rotary, meron tayong gear pump, screw pump, rotary vane. Meron naman tayong reciprocating, meron plunger, meron diaphragm, yung ginagamit in Tagalog, this is poso. Yan, diaphragm. Meron piston type. Reciprocating, ibig sabihin linear yung pag-pass niya, linear. Ayan. And then linear. Ganun din yun, pareho lang. Linear ang actuation niya, yung galaw. And for the centrifugal, ay dynamic, meron tayong centrifugal, tapos special. Centrifugal, meron tayong axis flow or axial flow, merong sa radius, radial flow. Okay? Pag radial, through the radius, and then mixed flow. Pwede magkasama. Then, meron tayong cantilever, may jet pump, may turbine pump kapag special. Those are special types. So, karaniwang ginagamit is centrifugal lang naman. Depende sa application of the head and then rotary. Or reciprocating. Now, for the reciprocating pumps, parang ano yan? Nakita niyo yung bomba ng hangin sa ano? Bomba ng hangin sa bola, the inflator. Yun ay reciprocating. Ibig sabihin yung linear actuation niya, meron kang mga ano dyan, valves. Kung saan yung valves na yun, pag pinasok mo or pinush mo, yung valves na yun bubukas in order for you to introduce air to the cylinder. Ngayon naman, kapag hinigop mo siya, pabalik, sasarado yung valve na yun. Ibig sabihin, making the fluid be contained inside the cylinder. Ganun yung reciprocating. So yan. It uses a piston and cylinder arrangement with suction and discharge valves. Yan yung sinasabi ko. Integrated into the pump. Now, additional information. Saan ba ginagamit yan? Commonly used as boiler feed pump for steam. Can be double acting or single acting. It can be simplex, duplex, triplex. Ito yung mga katulad. So, hindi natin pag-uusapan yan. Yan. Ngayon, ano ba pag reciprocating pump? Tandaan mo na ang discharge niya or Q is low. Ang head niya is high. Ang speed niya is low. At low speed applications and low discharge rates, you can gain higher heads using reciprocating pumps. Yan. Characteristics niya. Okay? Now, kapag discharge, mamaya sabihin ko sa inyo ng pinagkaiba ng size and discharge. Okay? Size and discharge sa pumps. Rotary pumps. Ngayon, meron tayong gear pump, may screw pump. Gear pump. It moves fluid by repeatedly closing a fixed volume using interlocking cogs. So, by gear. Ayan, by gear nga. Transferring it mechanically using a cyclic pump action. Vane pump, ganun din. So, ano yan? Discharge at low discharge, Q, low Q, and then low head. Yan. Application for viscous fluids or oil. Ginagamit itong gear pump na ito, saan? Nakikita niyo yung mga barrels ng yung mga drum, yung mga red drums ng fuel. Pagdating ng ng mga airport, hindi kasi kayo nag-aeronautics eh. Pero pag nakasilip kayo dun sa training facility ng aeronautics or ng mga airplanes, drum na jet fuel na nandun or drum na aircraft fuel. Ang ginagamit nila is a hand crank gear pump para i-refuel yung kanilang mga engines. And centrifugal pumps. Yung centrifugal pumps. So, meron kang inlet, ito outlet. Meron kang casing, ang tawag dyan, volute casing. Meron kang flange, ito yung drive shaft mo. Galing sa motor, dito ka nag-input ng power. Impellers and then ito naman yung outlet. Now, ano ba yung centrifugal? A pump in which the pressure is developed principally by the action of centrifugal force. Centrifugal. Center seeking. Tama ba? Center seeking. So, that is convert kinetic energy into pressure energy through diffuser vanes. Ngayon, ano ba yung application niya? Ano ba application niya? Siyempre, kapag kailangan mo na mataas ang Q or discharge, mababang head, at mataas na speed, dito ka sa iyong centrifugal pump. Okay? Yan. Ito naman yung iba. So, for radial, axial, and magkakaiba yung kanilang application. Now, for double suction pumps, kailan ba ginagamit to? Employed when the flow rate required becomes too large for the inlet cross-section to one impeller. Ibig sabihin, double suction. Ito yung pump mo, dalawa yung suction, 1 and 2. Hindi na kayang i-take up ng inyong inlet condition para maging outlet. Okay? Dinodoble yung suction niya. Okay. Deep well pumps, diaphragm type yan. Yan. Hindi na tayo pwedeng mag-deep well. Kailangan na tayong kumuha ng permit pagdating sa mag-deep well. Kasi nagkakaroon yan ng seepage sa ilalim ng lupa. Kaya, pag nagkaroon ng seepage, magkakaroon ka ng sinkhole. Yun ang dahilan bakit tayo may mga sinkhole. Yung deep well. Kasi, bakit? Yung soil mo, the top soil ng ating tinatapakan, yung ilalim niyan, merong tubig. And when that water supply is depleted, ngayon, yung ground mo will seep in. Ibig sabihin, lalambot ang lupa. Wala nang laman eh. So, yung top layer of your soil will go down. Kaya magkakaroon ka ng sinkhole. Yun yung dahilan. Okay? Ayan. Naman, based on suction lift naman, classification of pump. Shallow well pump, ito. Suction lift niya, ibig sabihin yung head lang ang pag-uusapan. Up to 25 feet lang. Deep well pump, ginagamit sa oil extraction. Turbine pump, kailangan ng higher head. Or high head, submersible na. Ibig sabihin, nilalagay mo sa pagkaila-ilalim ng fluid. Submersible pump. Now, cavitation. What is cavitation? Now, it is the spontaneous vaporization of fluid, resulting in degradation of pump performance. The formation of cavities of water vapor inside the suction side of the pump due to low pressure. Ibig sabihin, at low pressure, water boils. Tama ba? At lower pressures. At vacuum pressures, the lower the pressure, the lower the temperature that water will boil. Ngayon, kapag napakalit ang pressure mo under the pump, ang nagkakaroon dyan, cavitation. Ngayon, ano mangyayari pag cavitation? Sinisira niya yung pump. Bakit? yung mga bubbles na nakikreate nung low pressure na yon, pumuputok yon inside the pump. At pag pumutok yon, nakakasira yun ng vanes ng pump or the outer casing of the pump. Pressure difference inside the pump is very hurting pagdating ng ng pump mo. Kasi nga, yung pressures na yun at low pressures, water tend to boil. Now, ano ba yung causes ng cavitation? Sabi dito, the discharge head far below the pump head at peak efficiency. High suction lift, low suction head, excessive pump speed, yan, high liquid temperature. Kasi nga, mababa yung pressure. High liquid temperature. At lower temperatures, water tends to boil at lower temperature. Okay? How to prevent cavitation? Increase the height of the fluid surface. Number 2, reduce friction and minor losses. How would we do that? Shortening the suction line. To reduce friction, iiklian mo yung piping mo. Ngayon, mas maraming bends, mas maraming elbows, mas mahaba ang piping. Ang nangyayari, nagkakaroon ka ng head losses. Mas maraming pipes, mas maraming elbows, mas mataas ang head losses. So, mahihirapan ng yung pump. Okay. Number 3, reduce the fluid temperature at fluid entrance. Kaya nga meron tayong mga cooling pagdating ng bago mag-pump. Kinu-cool down muna natin yung tubig. Kino-condition natin siya. Okay? Pressurizing the fluid supply tank. Paano yun? O di yung tank niya, lagyan mo ng pneumatic system. Ibig sabihin, lalagyan mo ng induce ka ng pressure for distribution. Number 5, reducing the flow rate of the velocity or the velocity. Tama nga naman. Bagalan mo yung pump. Okay? Yan. So, what is net positive suction head? Yan nga yung static level, static head, or the potential head, pressure head, and to, friction head loss. That is net positive suction head. And NPSH. That is net positive suction head. Difference between actual suction pressure and saturation vapor pressure. Yun ang pagkapahulugan sa akin. Now for pump heads, pinaliwanag ko na sa inyo, ano ba yung friction head? Kapag sinabi sa problem, it is either Morse, ang mauuna kasi parate, Darcy. Ano ba yung Darcy? That is HF equal to FLB squared over 2G. Kapag naman nagbigay siya ng Morse coefficient, Morse ang gagamitin mo. Morse is FLB squared over G. D. Sir, nasaan yung 2? Kadikit ni F. Ayan. So, that is for the head losses. Now, for static head, the static head is the potential head din yan. Static head, HS, is Z, D, minus ZS. Kailan magiging plus ang ZS? Kapag, pag below center line. May paliwanag dyan. Kailan magiging positive ang ZS? Kapag above. May paliwanag ko dyan. Let me go back. Let me go back here. Tandaan nyo, yung head lang naman ang measurement natin pagdating dito eh. Okay? So, tignan nyo ito ha. Iaakyat mo siya at a certain head. Ima-minus mo ba i-add? Siyempre, i-add mo na lang. Okay? Bakit? Kasi yun yung hahabulin na head ng pump mo para may akyat mo dito. Kasama yun. Pagdating naman dito, matik yan, gravitational na lang ang effect niyan. So, kusa siyang bababa, papunta ng pump mo. Hindi mo na kailangan higupin yan para iakyat dito. Okay? Yung paghigop mo na energy, konti na lang ang gagamitin mo. Kasi, yung head na pababa dito will be additive na lang. Okay? So, ima-minus mo na lang siya dun sa discharge head. Ayan. Ganun yung paliwanag niya. Okay? So, for the pressure head, ayan, HP. P ni D minus PS over gamma. Ano ba yung fluid na yun? Ina-transport mo. Now, for the velocity head, HB is, yung tinuro kanina, V squared V squared over 2G. Yan. Suction lift, pareho lang yan. Suction head, yun din yun. Static discharge head, lahat yan. Total head. Now, for pumps in series and parallel. Ayun. Kapag daw series ang pump mo, it will increase the head. Okay? So, additive ang head niya. Ngayon, since pareho lang naman yan ng line, so the Q is constant. Ngayon, pag parallel, Q is additive, head is constant. Increasing, anong ginagawa natin? Ini-increase natin yung discharge or the flow of the volume. Now, sir, kapag sinabi ni engineer, pupunta kayo ng field, size, capacity. Anong pinagkaiba niyan, sir? Tinanong ako ng engineer, junior engineer, baka pwede mo na akong bigyan ng ganitong size ng pump natin. Ganun po ba? Size? Tinanong ka naman ni nung isa pang engineer, engineer, baka pwede mo akong supplyan ng ganitong capacity. Okay? What is size and what is capacity? Now, for the size of your pump, it pertains to the power. Okay. So, sir, size. Meron tayo dito, sir, mga 10 HP. Meron tayo ditong 100 kilowatts na pump. That is for the power. What if capacity? Sir, meron akong capacity dito na 3 GPM. Meron akong capacity dito na 100 LPS, liters per second. Ibig sabihin, the capacity is measured in flow. Ayan, volume flow rate. Okay? Now, you getting my point? Madali ba siya? Madali i-distinguish ang size sa capacity? Yes, kasi yan lang ang sasabihin sa inyo in order for you, pagdating nyo ng field, to determine what is the head of the pump and what will be the requirement pump that you will need. Okay? Now, ito yung typical pump installation niya. Diniscuss ko na ito kanina. Now, if it is your datum line, yan, ito yung datum line, CL. Ngayon, ito yung pump center line mo. Ito na yun. Magiging, diniscuss ko kanina, from the velocity, from the total dynamic head. Ngayon, meron tayong shortcut dito. Okay? Pump work. Pump work. So, P is equal to gamma QNX. Ano ko muna to? Baka muna. Bigyan nyo ako ng space. Okay? So, getting back. Pump work. Ngayon, pag SI units. I want you to know this. SI units. So, pump work is equal to gamma ng tubig, water, Q, tapos yung head total. Ano yung head total? Ano ba yung head total? Diba that is equal to yung head static o the potential head? Okay? Ganito na lang. So, JD minus JS plus yung velocity head. So, V2 squared over 2G minus V1 squared over 2G plus, ano to? P2 minus P1 over gamma plus yung head loss ni 1 plus head loss ni 2. Ayan. And yung itong Q in what unit? If this is in meters, in meters, itong Q is in, pwedeng GPM, pwede itong kailangan ang unit ito is in cubic meter per second. Ang unit nito is in kilonewton per meter cube. So, ang lalabas dito will be in kilowatt. Kilowatt. Sir, may shortcut ba tayo? Yes, my friends. May shortcut tayo dyan. May shortcut tayo dyan. Okay. Let me teach you another shortcut. Hindi lang naman tayo parating SI units. Okay? I want you to remember this. That the pump, okay, power is measured by what? Yan, pag may efficiency ka, gamma, Q, and H total. Divided by efficiency ng pump. Okay? Para ma-measure mo yung input power. Ano ba yung input power? That is the motor power. Okay? Now, this is input power to input power to the pump. Or, pwede rin tong motor power. Purahin natin to. Mali pala ako ng mali pala P dapat. Dapat motor. Motor or in. P in. This is the pump power lang. Yung power ng pump. Ngayon, sir, paano ko naman hahanapin yung input power niya pagdating ng pagdating ng English unit? Lo and behold, my friends. Kasi, meron tayong nagawang shortcut dyan. So, the input power of your pump, kapag English unit, is gamma. Huwag natin sama si gamma, tinatamad ako eh. So, Q, H, total, over, 3960 pump. Sir, nasaan yung gamma? Wait, i-convert na natin yan. You should have your Q in what? Convert mo muna. GPM. Gallons per minute. Gallons per minute. At ito, anong unit itong head total mo? In feet. This is the shortcut in order for you to know the input power of your pump. Okay? Convert mo sa GPM. Tapos convert mo sa feet. That will be in HP kagad. Ganun kadali. Ngayon, sir, meron ba tayong mga conversions dyan? Yes. Tandaan mo yung conversion. Na 7.481 gallon equal to 1 cubic feet. Liter to gallon. 1 gallon is equal to 3.785 liters. Okay? Ano pa, sir? Yung gamma. Tanda mo tong gamma. Gamma ng water, that is 9.81 kilonewton per cubic meter. Or 62.4 pound per feet cube. Ngayon, meron pa ako ituturo sa inyo pagdating ng calculation. Okay? So, let's move on. I-rewrite ko lang to, ha? So, ayan ha, P in. So, general formula. Gagamitin nyo to sa board exam. Q, H, head total. Divided by 3960 PP. Efficiency of pump. Ang lalabas dito is in HP. This is my shortcut. Okay? Now, for the characteristics ng centrifugal pumps, meron tayo specific speed. Paano kinukuha yung specific speed? NS is equal to N square root ng Q over H over 3/4. Ngayon, sir, ano po ba yan? Dapat yan, kailangan naka-RPM, GPM, saka feet. Ngayon, paano, sir, pagko-convert ko? Huwag mo na i-convert. Dapat yan, laging nakaganyan. Malilito ka lang. Okay? Ngayon, kapag SI units binigay dito, 51.65 N square root ng Q over H raised to 3/4. Where your Q should be in cubic meter per second and H in meters. Pero, mostly, ito lang naman ang gagamitin mo. Convert mo na lang parati ng English. And this is my technique. Ngayon, pag wala sa choices, kung mare, di ba? Always use the English units first. Wag mong gagamitin yung SI. Ngayon, pag wala pa rin doon sa choices, yung sagot ng specific speed, then that is the time you will use SI units. Okay? Let us proceed. Ngayon, pag similar pumps, ibig sabihin the specific speed ng iyong pump is equal. Okay. Meron tayong binigay dito na conditions. Ayan. Ayan. Pero sir, mas gusto ko kasi mas madaling tandaan eh. Okay. Another one. Bigyan kayo ng another technique. Okay? Yan. I-table nyo yan. Pag tayo nahihirapan, lagi tayo nag-table. Okay? So, Q, H, P. Tapos, anong mnemonic natin dyan? Mali ito ha. QHP. 1, 2, try new. I want to try new. Try to find dice. Okay? Yun ang sabi nila, Queen has power. Want to try now. Try to find out. Okay? Kaya ba 5 sounds like find. Okay? Queen has power. Okay, ganyan. Queen has power. Queen has power. Want to try now. Try to find out. Yan. So, meron tayong mnemonics dyan para hindi nyo makalimutan. Eh, sir, paano natin gagamitin yan? Huwag natin pansinin to, ha? Oh, huwag nyo pansinin to. Tuturo ko sa inyo yung hindi kayo malilito. Okay? Uh-huh. Hindi tayo. Hindi kayo malilito. Gusto ko maiintindihan nyo siya. Sir, what if? Ganito yan, ha? What if, yung sabi dito, 3 conditions. Pero 2 lang condition na papantayin na. What if, constant ang speed niya? Mm-hmm. What if constant speed? So, you try to cross out yung constant speed. Okay? Saan ba nagmula yan? Yan. What if constant speed? So, ibig sabihin, i-cross out mo to. Ano ba lang ang makakuha mo dyan? Constant speed. Okay? So, you have, bayin natin yung kulay dito. Constant speed. Okay? Pag constant speed, pwede mong gawin ganito. Okay? Q over Q equal to D over D. May makikita mo, this is the exponent. Ayan, no? Exponent niyan. Ibig sabihin, pag constant ang iyong speed, then you should say Q2 over Q1 equal to D1, D2 over D1 cube. Ayan, no? Kapag naman H, palagay mo yung H. Yung H naman, pwede mong gawin ganito, ha? Pag H naman, H over H equal to D over D. Yan. H2, H1, D2, D1. Nakaanong power? Second. Tignan nyo. Ayan, no? Diba? Ayan, no? Ayan siya. Diba? Paano naman pag power? Okay? Itong Q, flow, head, power. N is speed, D is diameter or size. Ngayon, pag power naman, hindi ang pressure, ha? Power. Pag power. Sige nga, pag power, that is power is 2 P1 tapos equal to. Ilan yung power niya? D2 over D1 raised to 5. That is constant speed. Ngayon, paano naman po sir kapag constant ang size or diameter? Constant naman si diameter, kaibigan. Gawin natin kulay. Constant diameter naman. At i-cross out mo to. Kumbaga, tatakpan mo lang siya. O, takpan mo yan. Okay? Takpan mo siya. Constant diameter, ibig sabihin, tignan mo si Q. Q, 2 over Q1. Tignan mo yung power. Yung power niya. O, D1. O, N2 over N1. O, 1 lang. Paano naman kapag head? H2 over H1. 1, 2, try. Equal to 1, 2, try. 1, 2, 3. So, N2 over N1 squared. Paano naman kung power? 1, 2, try. So, 3. 2, 1 equal to N2 over N1 cube. Okay. So, ganun lang siya. Huwag nyo muna isama to. mas maganda isama siya pag fans na. Okay? So, this is N constant. Ito naman, P is constant. Ngayon, saan ko ba makikita yan, sir? Okay. So, ganito yan. May technique pa ba tayo dyan, sir? Yes, there is. Medyo hindi ko matandaan, sir, yung want to try na. Try to find out. Sige, ganito. 1, 2, 3. Bilang ka. 1, 2, 3. Okay? Ito naman. Tatanggalin ko itong mga to, ha? My friend, tatanggalin ko sila, ha? May technique pa ba? Ang daming technique pagdating ng pump. Buti na lang napunta kayo sa akin dahil ako ang expert sa pagbubomba. Joke lang. So, hindi kayo nawalan. Okay. So, sulat ulit natin. Queen has power. 1, 2, try now. Try to find out. Okay, tapos na kasi. Out na. Yan. So, let us leave that blank. And sir, medyo nakakalimutan ko kasi kung gagawin ko ganito ba, constant speed o ano. O wag mo muna sabihin constant speed. Hindi rin natin sasabihin constant size or the same size. Ganito ang gawin natin. Q over Q. Ito munang buo na to. Okay? Ito muna. Saka ito. Itong dalawa. Okay? Q equal to N over N. Tapos, D over D. Hindi ka malito. Oh, ganito. Okay, lagay ko dito si 2. Lagay ko si 1. Lagay ko si 2, lagay ko si 1. Lagay ko si 2, lagay ko si 1. Ngayon, ano yung power dito ni N? That is 1. Ano yung power dito ni D? That is 3. Ngayon, pag sinabi siya na constant size. Oh, constant size, same diameter. Oh, di cancel mo. Oh, yan, meron ka na. Okay? Paano naman, sir, pag sinabing constant ang speed, di cross out mo lang yan, di meron ka na ulit. Di ba ganun lang? Another one. Paano naman kung ito kukunin mo? Si H. Ngayon, copy mo. H over H equal to quantity N over N. Tapos, D over T. Ngayon, ano yung power? Lagay ko muna dito si 2, si 1, si 2, si 1, 2, and si 1. Ano yung power dito, okay? Tignan mo, 2 and 2. Sir, paano naman, sir, kung constant si speed? Di cross out mo yan. Di meron ka lang nito. Takpan mo lang ito. Ngayon, sir, paano kung constant size naman? Di takpan mo ito. Di meron ka na. Di ba same lang yan ng mga nandito? Ayan, di ba? Ayun lang, ayan, di ba? Di ba madali? Paano naman kapag power? Okay, dito naman tayo. Kay power naman. Lista mo ulit. Madali tayo makakaintindi dito pag alam natin yung mga technique. Okay? P over P. N over N. Yan. Tapos, D over D. So, 2, 1, 2, 1, 2, 1. Ngayon, ano yun dyan nakalagay na power? 3 and 5. So, ang power ni N is 3. And then 5 ito. Sir, sabi nung kaibigan ko, same size daw. Sabi nung kaibigan ko, same size daw. Di same size. Pag same size, di cancel mo. Tignan mo ito. Nandito ba? Ayun, diba? Ayun siya. Sir, paano naman kung same speed? Tignan nyo natin. Saan siya? Ayun, diba? Ayun, Okay? So, ganun lang kadali ang paggamit ng ating pump. Anong tawag dito? Pump affinity law. Okay? That is very basic. Now, for your reciprocating pumps, ito lang yan. Meron kang reciprocating pump, ibig sabihin a piston displacement pump. Ngayon, if rod is neglected, BD is equal to, ano ba yan? Ito yung general formula. BD is equal to 2A LN. Ibig sabihin, double acting. Double acting yan. 2A LN. paano mo na makukuha yan? Okay, BD is equal to 2. Ano ba yung area ng piston mo? Cylindrical. O di pi over 4. Ano yon? D squared L and N. Yan. And then, simplify natin. It will be pi over 2 D squared L N kapag double acting. Ngayon naman, paano naman, sir, to know the speed of the pump? In order for you to know the speed of the pump, V, velocity, is equal to linear times N. L, the length times N. Ngayon, pag kinonsider yung percent slip, BD is equal to, slip is equal to BD minus the Q. Ngayon, the percent slip, ayan na. Volume displaced, ayan, negative Q. And volumetric efficiency is equal to Q over BD. Okay, so that will be all for the pumps. I hope you get the point, lalo na yung pagdating ng ating similar pumps, geometrically, and then to the speed. Yeah, that means below. That will be all for today. I hope you will grasp the idea. And next will be the problem sets na ginawa. So we will solve 17 problems from your Bernoulli's equation and then 10 problems to your pump at different difficulty levels. Okay? So see you next meeting.